To understand elastic potential energy, consider the example you see here, where we have a ball that's moving with some kind of kinetic energy and then slams into this spring. Now, when the spring compresses and at the point where the ball is at rest for a brief moment before being launched in the other direction, it has no kinetic energy. So the energy had to have gone somewhere. In this case, it can only have gone into the spring. So the spring compresses, stores that energy, and then it will release that energy when it launches the ball back in the other direction. So in order to understand that, we just have to realize that the energy is not gone. Okay, it's stored in that spring, and therefore we must have some kind of elastic potential energy. Now, to calculate elastic potential energy, it's very similar to the kinetic energy equation with different variables substituted in. So the elastic potential energy in a spring is equivalent to 1/2 of that spring's spring constant times the extension or compression of the spring from its resting position squared. Again, you only square the displacement of the spring. So the elastic potential energy is EEP measured in joules. The spring constant is, as from Hooke's law, measured in newtons per meter and refers to the stiffness of the spring. And delta X is the displacement of the spring from its rest position, from its resting length. And the displacement of the spring is the only portion of that equation that is squared, nothing else.